Hi everyone, it's Professor West, and it's going to be a chilly next couple of days, so for us to not get behind, I'm going to upload some video lectures. So our first step would be to finish our 1.1 notes. So we're going to start with 1.1, linear equations and rational equations, continued. And we left off on this example, which was determine whether the following equations are conditional equations, identities, or contradictions. And here we have part A, which is 4x plus 1 minus x equals 6x minus 2. So as you know, the first step is just to rewrite the equation. So I'm just going to rewrite it below. 4x plus 1 minus x equals 6x minus 2. All right, our next step is to combine like terms. And on the left-hand side here, I have two terms with an x in it, so I can combine them. And we secretly have a 1 right here. So I have both a 4x plus 1 and a minus 1x. So 4 minus 1 is 3, so when I combine them, I get 3x. And then that plus 1 just stays the same. Equals, and on this right-hand side, there's nothing to combine, so that's 6x minus 2. All right, now I'm going to want to get all of my x's to one side. So you can either do this by subtracting 6x from both sides, or by subtracting 3x from both sides. I'm going to subtract 3x from both sides to avoid getting a negative number. So I'm going to go 3x plus 1 minus 3x. Let me move that over a bit. Equals 6x minus 2 minus 3x. So that will give us on the left-hand side just 1. And on the right-hand side, that will give us 3x minus 2. Now I want to get all the non-x's onto the same side. So I'm going to add 2 to both sides. So on the left-hand side, that means I'm going to get 1 plus 2 equals 3x minus 2 plus 2. So on the left-hand side, I just get 3, and on the right-hand side, I just get 3x. Okay? Now I'm going to want to multiply both sides by 1/3, or 1 over 3, to get rid of the 3 on the right-hand side. So I'm going to go 1 over 3 times, I'm going to move that over, 1 over 3 times 3 equals 1 over 3 times 3x. Okay, and that will give us 1 equals x. Now this is not what the question was asking, right? The question was asking us if this would be a conditional equation, identity, or contradiction. And if you remember from our definitions the other day, this would end up being a conditional equation since it has a definitive answer, x equals 1. So our answer is going to be conditional equation, and then we want to say what our solution set is. So to do that, we're just going to make a set, which is just squiggly bracket, put in our answer, and then close the squiggly bracket. You'll see something like this on Alex. And then we're going to box in our answer. So I'm going to box in our answer. So for our first problem, our first part, since we got x equals 1, this is a conditional equation. Let's move on to part B, so then we can see what the other two look like. So, part B. Part B is going to be 2 times the quantity of 3x minus 1 equals 6 times the quantity of x plus 1 minus 8. All right. Again, the first step is just to rewrite the problem. So I'm going to go 2 times 3x minus 1 equals 6 times x plus 1 minus 8. So our first step will be to distribute. So I'm going to want to distribute my 2 to this 3 here, and I'm also going to want to distribute my 2 to this negative 1. So I'm going to want to distribute, again, 2 to the 3x, 2 to the negative 1. Oops, sorry about that. So 2 times 3x is 6x, so I'm going to write that down, 6x. 2 times negative 1 is negative 2, equals 6 times x, because we have to do the same thing over here. 6 times x is 6x. And then 6 times 1 is 6. And then we bring down that minus 8. Now on the right-hand side, we need to combine like terms. We don't need to do anything on the left, so we'll just rewrite that. 6x minus 2. And then on the right, we need to combine that positive 6 and negative 8. Positive 6 plus negative 8 is negative 2. So we will get 6x minus 2. Now, we can notice that these here are the same. These are the same. And that's important here. Them being the same means that if we were to try to solve for x and get all of our x's onto one side, we would end up getting negative 2 equals negative 2. So try it yourself. So try subtracting 6x from both sides. You'll get negative 2 equals negative 2. And then you could add 2 to both sides, and you would end up with 0 equals 0. And you should pause the video and try it for yourself. See if you can get 0 equals 0. But getting anything that is the exact same equaling anything else that's the exact same, that is what is called an identity. So our answer here is identity. And the set for an identity is all real numbers. So I'm just going to draw that fancy R we've been seeing for the set of all real numbers. I'm going to box our answer in. So if you get something where it's the exact same on both sides, it is the identity. All right. Let's move on to part C. Part C is 2 times the quantity of negative 5x minus 1 equals 2x minus 12x plus 6. All right. First step is just to rewrite the problem. So that's 2 times negative 5x minus 1 equals 2x minus 12x plus 6. So the first thing that we're going to want to do is distribute on the left and combine like terms on the right. So on the left-hand side, we're going to distribute. 2 times negative 5x is negative 10x. So I'm going to write that down. Negative 10x. 2 times negative 1 is negative 2. So minus 2 equals. Now we're going to combine like terms. On the right-hand side, we have both 2x and negative 12x. So 2 plus a negative 12 is negative 10. So 2x combined with negative 12x gives us negative 10x. And negative 10x plus 6. Now I'm going to want to get all of my x's onto one side, so I'm going to add 10x to both sides. So I have negative 10x minus 2 plus 10x equals negative 10x plus 6 plus 10x. Okay, so if I add those to both sides, on the left-hand side, I get negative 2, and on the right-hand side, I get 6. Now, does negative 2 equal 6? Is there any way that this could be possible? The answer is no. Negative 2 can never equal 6. So this is what is known as a contradiction. So it cannot be equal. Cannot be equal. So we have a contradiction. And we denote a contradiction by the empty set. Now an empty set is just two squiggly brackets with nothing in them. And that, it would be our answer. So here we have the 3 different equation types, which are a conditional equation, in which we get a solid answer. We have x equals something. Here we have an identity. We get that from getting something equals itself, like 0 equals 0, or 6x minus 2 equals 6x minus 2. Something that is the same. And then we have a contradiction. We get a contradiction from something that is false, meaning negative 2 does not equal 6. That's just false. We can't have that, so that is a contradiction. And that concludes this example. So let's move on to a definition. So, rational equation. Rational equation. So, a rational equation is an equation that contains a rational expression, excuse me. Okay, a rational equation is an equation that contains a rational expression. And you will be asked to solve these rational equations. So, why don't we just test one out here? So, example. Solve. I'm going to kind of write it like this. Solve 1 over x squared minus 9 equals 4 over x plus 3 plus 1 over x minus 3 for x. For x. Okay. So the first step, just rewrite the problem. So I'm going to have 1 over x squared minus 9 equals 4 over x plus 3 plus, let's see if I can get this here, 1 over x minus 3. All right. So what I'm going to do first is I'm going to factor this denominator here, since it's factorable, and we're going to want to be able to find the least common divisor of these. So if you recall how to factor a difference of two squares. So recall that a squared minus b squared equals a plus b times a minus b. So our a in this circumstance is x, and our b in this circumstance is 9. So, our b is 3. That is because 9 is 3 squared. So our a in this circumstance, here maybe I'll even write it down. Our a in this circumstance is x, and our b in this circumstance is 3. And this is because 3 squared equals 9. So what does that mean for us? That means that x squared minus 9 equals x plus 3 times x minus 3. All right? So we can replace our denominator here with x plus 3 times x minus 3. So why don't we do that? So I'm going to go 1 over, and make this a little bit bigger, 1 over x plus 3 times x minus 3 equals 4 over x plus 3 plus 1 over x minus 3. And now it's super simple to see what our LCD is. So our LCD is just going to be x plus 3 times x minus 3, since they all contain a piece of one of these, right? This one on the left is just x plus 3 times x minus 3. This one here contains the x plus 3, and this one here contains the x minus 3. So that is our LCD for this situation. Now, we're going to want to multiply both sides by x plus 3 times x minus 3. So let's do that. So I'm going to get x plus 3 times x minus 3 times 1 over x plus 3 times x minus 3 equals x plus 3 times x minus 3, because whatever you do to one side, you have to do to the other. Times 4 over x plus 3 plus 1 over x minus 3. All right. So over here on the left-hand side, this is all just one term. There's no pluses or anything in the numerator. So that means that this will reduce to just 1. Since we have x plus 3, here, we have x plus 3 times x minus 3 in a numerator, right? You could pretend that this is all over 1, right? And then we have x plus 3 and x minus 3 in the denominator on this side. So that would eliminate them, and we would just reduce to 1 here. So then we're going to get 1 equals, now on the right-hand side, I'm going to want to distribute, just like we did in previous problems. I'm going to want to distribute to here, and then I'm going to want to distribute to here. So what does that look like? Well, that looks like x plus 3 times x minus 3 times 4 over x plus 3 plus x plus 3 times x minus 3 times 1 over x minus 3. All right, so now here, you can pretend that these are all over 1 again, if you would like. And here we can see that my x plus 3 would essentially cancel with this one in the denominator, giving us 4 times x minus 3 over 1, or just 4 times x minus 3. So we get 1 equals 4 times x minus 3. Okay? And same thing over here on the right. Same thing on the right. In the numerator, I have x minus 3, and that will cancel with this x minus 3 in the denominator. So I'm going to get plus, because I'm just carrying this plus sign down, plus 1, since that's all that's left, 1 times x plus 3. And now we're going to want to distribute again. So I'm going to distribute 4 to x and 4 to negative 3. So I'm going to get 1 equals 4x minus 4 times 3 is 12 plus, and now I'm going to distribute this 1, but that's just going to leave us with x plus 3, since multiplying anything by 1 is itself, so that leaves me with x plus 3. And now this turns into a linear problem that we're used to solving. So I'm just going to combine like terms on the right-hand side. So I have 1 equals, I have a 4x and a regular x. So 4x plus 1x is 5x. So 1 equals 5x. And then I have a negative 12 and a 3. So negative 12 plus 3 is negative 9. So I have 1x equals 5x minus 9. So now I want to get the x by itself, so I'm going to add 9 to both sides. So I'm going to go 1 plus 9 equals 5x minus 9 plus 9. So on the left-hand side, I'm left with 10 equals 5x. 10 equals 5x. And now I want to eliminate the 5x, so I'm going to multiply both sides by 1 over 5. So I get 1 over 5 times 10. Oops, my bad there. Times 10 equals 1 over 5 times 5x. So on the left, 1 over 5 times 10 is the same as asking what is 1/5 of 10. 1/5 of 10 is 2. So I get 2 equals, and on the right-hand side, 1/5 of 5x is just x. Now, you might want to box your answer and say this is the answer. However, this is very important, okay? Important. So much, I'm going to capitalize it. Very important note I'm about to make. If an x is in the denominator, we must check our answer. So if there was ever an x in the denominator and we started this problem, we must check our answer. So, how do we do that? We're just going to check. We're going to plug it back in and see if it gives us any weird business going on. So we're going to check it. So I'm just going to go 1 over, plug it in, 2 squared minus 9. Does that equal 4 over 2 plus 3 plus 1 over 2 minus 3? Well, let's find out. On the left-hand side, that will give us 1 over 2 squared is 4 minus 9. Does that equal? On the right-hand side, we have 4 over 5 because 2 plus 3 is 5. 4 over 5 plus, now 1 over 2 minus 3, that's going to be 1 over negative 1. So let's keep going and see what we get. So 4 minus 9 is negative 5, so I'm going to get 1 over negative 5. Is that equal to 4 over 5? And then 1 over negative 1 is just minus 1. So is that the same as 4 over 5 minus 1? Well, let's get our negative 1 into a base of 5, so that way we can subtract and see. So on the left-hand side here, I have negative 1/5, and I'm wondering if that equals 4 over 5 minus 5 over 5. Since 1 can be turned into any number over itself, notice 5 over 5, this would reduce to 1, right? So we're allowed to do that. So 4 over 5 minus 5 over 5 is negative 1 over 5. So I get negative 1 over 5 equals negative 1 over 5. And that works out, so I put a little check. So this means that it is true. Our final answer is x equals 2. And again, the reason we did all that is that you must check. You must, I'm going to come back up here. You must check your answer if x is in the denominator, because you could get extraneous solutions. And so that here, let me zoom out here. is how you would solve a rational equation. So you just want to find the LCD as we did here. You want to find the LCD. Actually, let me get a different color so it's easy to see. You want to find the LCD as we did here. Multiply both sides by the LCD. Distribute it as we've done before. Solve the linear equation that pops out. See, a linear equation pops out. Solve for that and get an answer. Now, when you get an answer, you need to check if it's true if x was ever in the denominator, which it was, right? So we're going to check, and our check is using the equation from the original problem. So you want to make sure you're checking from the original equation. And when we check, you want to get that little check mark that says, yup, we get a true statement. -1/5 equals -1/5. And if that's true, then your answer is the one that you thought previous. So that concludes our 1.1 notes, and I will see you for 1.2. Have a great day, guys.